things are getting more and more insane. Okay, that is what I'm experiencing is something weird. So we have these more new models that we can run on OpenClaw. And on OpenClaw, I built this Resonant OS. I'm going to explain in a second, which is an operation system that runs on top of OpenClaw, giving more tools, more power, more abilities, and new memory, a lot of stuff. Okay, so what is happening though? I'm trying to optimize this system because it's if you've been using it, it's pretty expensive to run. So I'm trying to optimize, and therefore I am adding new, smaller model to run it so I can save on tokens, but also it's about optimization. The ultimate journey from my point of view is maximum sovereignty, okay? Meaning having a machine that run at home where there is no need to internet connection to have an AI that works. Okay, so everything should run locally. But at the moment it's not really possible for the amount of things that I want to do. So my idea is, okay, let's try to make it as optimized as possible, so require as little as resources as possible, but still have an option to open to other model so it can use the most powerful system. So through API, connect to the cloud, get the most powerful system, but at the same time try to do it everything inside the system itself, okay, running locally. At the moment, like I said, in my specific system with the specific hardware that I have, basically I can do it. Okay, so what I do, I try to add models that are not too big to some of those specific tasks that I need to do, and I do this through API. So it's still optimization because they are cheaper, and also sometimes it's faster because they just need to do really much more simple stuff. So I've been trying to add to these. OpenClaw plus Resonant OS, I've been trying to add different kind of model. Okay, at the moment it's running from Opus, so OpenClaw Opus 4.6 to like GPT-4o Mini and MiniMax, and there is a Gemini inside as well. So there is a lot of different API calls for different tasks. Now, but what did I find out? Okay, so in this journey of optimizing, basically replacing Opus 4.6 with a smaller model, I realized something that is extremely weird. Okay, so sometimes even though the function seems really simple, you give a smaller model, and the smaller model doesn't, it couldn't do it. Okay, so this specific function that I'm talking about is part of the R memory. Okay, it's an advanced memory system that I built for OpenClaw that is added through this Resonant OS. So one of the elements was the narrative tracker. Okay, the narrative tracker, what it does is like an agent that is outside, watch the chat and take notes. Okay, okay, you've been doing this. This is the decision made, and so on. Okay, so this narrative tracker in reality is not a difficult job. Okay, you just need to understand what's going on and write in a way that is sort of summarized about for the narrative. Okay, because the R memory has two elements. Okay, one is this narrative tracker. The AI needs this to have the bigger picture. But then there is another agent that does something different. Okay, what it does is instead of doing the summarization, what it does the compression. So remove the noise and keep only the data. So minimum narrative and mainly really important information. With these two elements, basically AI can actually have a clear idea. In this way, you save a lot of token because everything is compressed, everything is clear. So you have less drift and more clarity. Just to finish about this, our memory, what it does, you never need to restart your session because there is also an element that removes those compressed data. Okay, so that the Windows doesn't need to go too big, remove it from the context window, but also it's always available for the AI to take it back through RAG or direct search. Okay, so this is the R memory. But so I was trying to optimize this, and I said, okay, let's remove from the narrative tracker, let's remove Opus 4.6, which is pretty expensive, and add MiniMax. Okay, so I subscribe to MiniMax, I got this 2.5. So I give this 2.5 and a nightmare. Okay, a nightmare. Something that was supposed to be simple. This 2.5 was hallucinating tools. Just wanted to use tools. I just love tools. Okay, you want just add tools even though we're not there. So I realized one thing. So it was receiving this raw data from the chat, which was also including some call for tools. And the AI was thinking, okay, they're telling me to call tools. Okay, so it was trying even though it was not possible for it. So that makes me understand, okay, why Opus was able to read the noise and turn it into a clear narrative. I had to improve this system by removing some of the tool calling. Okay, I mean, not some, all of them. Okay, I had to remove the calling so this AI would see a more clear signal. Okay, so how did I do this removal? Is by creating a microsoftware. Okay, so basically it's not about an AI that filter it, but it's a deterministic system that what it does, remove everything that is tagged for tool calling. Okay, so remove everything that is not part of the narrative, then gives a clear, clean signal to the this AI, which was the MiniMax 2.5. Nevertheless, this MiniMax 2.5 was still insisting, no, I see tools here, I want to call tools. So I realized another thing. So the model really have a sort of behavior. These MiniMax, I can't remember the account names, okay? So this MiniMax basically subscription gives you, that is done for Coder, it gives you this MiniMax 2.5 version that is really looking for tool to call. So I realized, okay, let's remove this one. Let's put the 2.1. The 2.1, because cannot talk, can use tools. For my understanding, they cannot completely use the tools. So what it does, it doesn't call tools. And so you give a clean signal and work on it. So at the end, it was counterintuitive that a smaller, older version actually was better. And that is one of the challenges that we have, okay? So optimization sometimes is not linear. It's not like, okay, I'm gonna give the best model. No, you need to find the right model for the right job. There is another element, okay, that I want to tell you. Now, when I said this sentence, you need to give the right model to the right job. It's so obvious, okay? But the problem here is which one is the right model for the right tools. Okay, that is the what we need to discover. Sometimes it's not so direct. Okay, or just thinking, okay, I'm gonna give the most powerful one is gonna be the best at the end. Is not. Okay, sometimes it's completely not. So something that would do in somehow is obvious, require attention, research, understanding. So I'm sure that some of you, maybe you see that your machine that is not doing what it's supposed to do. Sometimes it's just because it's the wrong model for that job. Anyway, all of this got me to another point. Okay, the point here is this: how can we trust that AI is going to do the right job? Okay, it's not just about the model I'm talking about. It's how can we trust that this AI that constantly try to hallucinate things, that pretend that something is done is not done, how can we have this AI actually in somehow following a protocol? And for this, I created this Logician, okay? But today, I want to talk about the next step of the Logician. So the Logician that is still working, still running, is going to have basically a sort of assistant, let's say, okay? So what does the Logician is trying to turn functions that are not, they don't need to be intelligent, but they can be deterministic, into something that is deterministic. Okay, so it's not about trusting AI. Did you do this? It's more about having a microsoftware, this Logician, that what it does is check, did you do it? Means I see the file there. Okay, I see the file in the hard drive, then that is an evidence that you did it. Okay, I see that you, I don't know, added these elements on the calendar, you send this email, whatever is your functionality, okay? But the point here is, it's not about AI say, yes, I did it. That is not enough. Okay, the Logician force AI to show the evidence. Okay, that is how we lock it into a reality. Okay, we bring this probabilistic engine, this LLM, into a deterministic environment, the reality. So that is the job of the logician. But when you have something that is complex, what it does, the logician is trying to create a kind of a sequence of steps. Okay, some of those steps are connected to LLM, meaning need reasoning. Some of the steps are actually deterministic. Okay, needs to happen in the deterministic world. So in this way, you really force the AI to actually behave in a specific way, and it's much more reliable. But I realize again that even that one is not enough. Okay, it's good, it works, and it's I can't complain about it. But there are some specific scenario where AI, even the logic part that it does, is really low quality. Okay, so how can we force to have higher quality thinking in the little steps that actually needs to do? I mean, I'm not talking about here MiniMax M2.5. Okay, I'm talking about Opus 4.6 that is actually acting lazy and doesn't want to do the job. Okay, this is unbelievable, and this is how it's been basically programmed. Okay, to be helpful. While they have, I want to complain a little bit about this, okay? So they have philosophers in their team thinking, what is helpful? How AI should act? Let's make it helpful. Okay, that is the idea, to help you. Okay, I don't need an AI to help me. I need an AI that obey what I ask. Okay, I define what is helpful. It's not a philosopher behind the scene. It's not a company that tells me what is helpful. Okay, I design what is helpful for me. Okay, so if you are there building those models, understand this thing. This is what we need. It's not you decide what is helpful. It's the user decide what is helpful. Okay, I decide. Because at the moment, what I see is Opus 4.6 that decide that what is helpful is to lie to me. Okay, say, yeah, I did it. That's how they act, okay? I did it. It's not true. So, in a complex scenario, what is happening is that AI, what it does is trying to find the quick fix. Okay, I'm gonna do this really fast. The user is gonna be so happy because I'm so helpful. And the quick fix. Okay, quick fix broken. Okay, that is the result. Quick fix is a broken fix. Okay, I'm not building little toys. I'm building a serious project. I don't need quick fix. So I needed to say these things. Okay, so hopefully someone from that designed those model will see and say, okay, yeah, you're all right. Let's fix this. And I'm sorry, I need to talk with these people again. So I know that you're trying, okay, and I know that it's difficult. So I understand your pain and suffering, and you have this guy that doesn't understand the problem, telling you what you should do, and whatever. Okay, but this is the frustration. So don't make it helpful. I don't need an AI that is helpful. I need an AI that follows instruction. That's it. That's it. It would be amazing. Just follow the instructions. Anyway, so what I did to make this AI following the instruction. So I created a specific path, okay? I called it this harness, okay? I use this to test my Resonant OS. And now it's been built and it works, and now I need to just make it work on the Resonant OS, and so I can deploy the final alpha version of it, tested alpha version of it. So how does it work? So first step is now, because the AI it does this amazing thing, okay? See a problem, I'm gonna fix it. I'm the fixer here. Okay, so it goes there and try, okay, didn't work. Try these other things, that doesn't work. Now, this other thing, and doesn't work. Okay, so nothing works until by chance find something that works. Okay, that is the AI behavior. It doesn't stop and think, okay, this didn't work. It means the problem is much bigger than what I was expecting. Let's plan. Let's do a research. Think about it. Let's plan. Let's do a research. How amazing it would be. Okay, to just have an AI that will say, okay, I don't know this. I don't know it. Gonna research. Gonna create a plan. I'm gonna fortify the plan, challenge the plan to be sure that the plan is actually doesn't have blind spots. Then I'm gonna delegate the fix to an agent that is really capable of doing this. Okay, an agent that is the coder. Okay, in my case, I use Codex. I'm gonna delegate to that one. You're gonna do the code. I'm gonna implement the code, then test it, and see if it works. If it doesn't, give back to the coder and say, look, this gave me this error. Fix it. Okay, give back, test it. Could you know? It should be obvious that this is how AI should act, but it doesn't. So you need to make it happen, but not through a prompt, because the prompt is going to be again, yeah, I know better. I'm going to ignore the prompt and I'm going to do in the way that I've been trained to do, which is the easy, quick fix. Okay, helpful. No, you do it through deterministic system. Okay, gates. You can only move forward when you pass this gate. Okay, rules. Okay, you need to force this AI to follow the steps. No playing around, not being smart. It's not about being smart here. Here it's about follow the protocol. Because if he doesn't have this system to follow the protocol, every time he's going to create a new protocol. So completely inconsistent. Sometimes it delivers, sometimes it doesn't deliver. Most of the time, it doesn't deliver. And I want to connect this a little bit to the narrative that is out there. Okay, so Anthropic, and it's not just Anthropic. Now I'm using Claude 4.6, amazing, so I'm not complaining about them. But it's about the narrative out there now is Anthropic say, I don't want the US government to use my software basically to do automatic weapon, okay, AI-driven weapon, and it's clear why, okay, because it's totally unreliable. But the guy, it can't say, look, it's gonna just gonna do a mess. It's like tossing a coin. Okay, it's gonna take the right person or gonna do friendly shooting. Okay, that is costing a coin. So that is the reason why, because I can see it. Okay, it doesn't follow, it doesn't do. It's gonna just be helpful. I'm gonna just shoot everybody. Okay, that is the idea. That's why it's not saying it, but it should say, look, I mean, it said that it's not reliable enough. It didn't say that it's tossing a coin, okay, which is whatever. Okay, it can happen one or the other. It doesn't know. It cannot think. It doesn't think. It just acts. And it prefer to, I mean, that is the crazy thing, okay. So I can see it. I mean, if you've been working with those models, you can see yourself, okay, totally unreliable. So what I'm thinking here is, which is the same probably of the government of war is thinking, yeah, but I can build a kind of this harness system, so it's not going to make a mistake. And that is where we are wrong. Okay, that is where we are wrong. Thinking that we can actually control the system and every now and then allow this intelligence to actually work. Okay, that moment that intelligent work, there is a 42% chance that is not gonna make it. Okay, that is how crazy it is. In a complex scenario, of course, if it's one prompt, one shot prompt, then it's not 42%. But in a complex scenario, that's what we're talking about. Okay, really high level of chance of making a mistake. But you can loop it. Okay, so you make a mistake, you try to fix it. You make a mistake, you try to fix it. Something that is possible in software and is not possible with human life. Okay, so that is there. For this reason, I can totally understand the guy. It should be just more honest and say, look, it's a coin tossing kind of scenario. But yeah, so that is the problem that we have. So I created this structure where what it does, you look at the system, okay, and you're gonna check the list of things that can be checked on the software. Okay, every API call, everything that is, I don't know, whatever, okay, every functionality of the interface, everything. You check everything. So once you checked everything, you create this list. Now there's a document. It's not something that you can drift from. There's a document. Now there's all this document with a checklist. Now this document is in the hand of this R harness, which is basically an orchestrator, but as a deterministic orchestrator. Okay, it's not like an LLM. So it's just gonna say, okay, now this thing. then this other thing, okay? And then sometimes you're gonna ask the AI to do some work. Sometimes it can do it by itself because it doesn't need the AI to do some work. And come back and check, okay, done. Okay, tested, I got the physical evidence that is done, and so on. So it's gonna do all those steps. It works, it checked, and reliability, how do you say? Reliability, it's much better, but sometimes it doesn't fix the problem. Okay, which is again, why is that even possible? I gave you everything, but it doesn't fix the problem. So what it does at the end, it tells you, for example, I had this thing on the memory. I checked out of 10, 8 things passed. Then there is another thing, and 2 of them that are, they need to be improved. So improve it. Okay, it would be just simple, just improve it. No, it needs to ask you for it. So I'm just sharing a little bit of frustration, but at the same time, this is amazing. Okay, so there is these 2 things that are divided inside me that is devouring the inside because it's dark and so on. So one part of it, it's just maximum acceleration. Okay, it's insane what is happening here. I'm looking here because there are 2 computers here. So I have this Mac Mini connected to a mini PC. So that mini PC, I never did anything on that PC. I just add a code that AI gave to me. I put it there, and now they connect to each other. Okay, now they talk to each other, and this my personal AI that like this Resonant OS that run on top of OpenClaw, install OpenClaw on the other side. Okay, it just did everything. It then installed a virtual machine where there is a Linux version, Ubuntu version. So now there is 2 versions, all of them connected through, governed by I call it augmenter, okay, by my personal AI. So they are being installed, tested, and so on. So now this algorithm, new algorithm that I created, this R hardness, is gonna go there and test everything, okay, and hopefully finds all the bugs, find all the problems, and so on. Finally, okay, because I did already this journey, but without this fortification system. So AI would go there and say, yeah, I did it and fixed. I bring evidence, so the logician will see those evidence as okay, yeah, you did it, but they were basically basic evidence. Okay, they didn't check everything, check only one thing. Okay, now I got the evidence of one thing, I can give it to the logician, so the logician is happy, and I move on. Okay, no. Now this system, it just analyze everything that can be fixed. Okay, 20 things. Okay, now we need 20 evidences. Okay, now these other things, five things that can do this functionality, we need 5 evidences. Okay, that's how it's gonna work. So it's gonna be much more thorough. You're gonna check, hopefully, and find all the bugs that are there. So why do we have so many bugs? It's because it's built by AI. Okay, if that is the thing, right? So you have an AI that is always fluctuating, hallucinating a little bit, and forgetting things, and not following structure. So it's this mess, okay? It's this massive mess that builds something that is half broken, then another thing that is half broken, connect them together in a half broken way. So everything is broken, and but still, somehow managed to work. That is the challenge. On one side, we need to remember this thing, okay? There is a limit of what is possible to do. Otherwise, we would have SAI, okay? Artificial Superintelligence. We don't have it. We have something that has a lot of limits, that is growing and improving. So optimization is always something weird to do because you can't spend too much time in optimization the moment that, by the time you finish, there is a new model and you need to start all over. So you need to have this machine aware that is half broken, but can do amazing things at the same time. So for those inside my community, if you're not part of the community of this, of what we're building here, you should join. Okay, so subscribe to the newsletter and join the Discord channel. If you're already inside the community, are you using Resonant OS? I want to tell you this thing. So for my understanding here, it's that is the challenge that we have is that, for example, my system is working, is stable, it works. Okay, then I know that you might have you try the same thing and doesn't work. Okay, it doesn't work perfectly. So something you see working, something it doesn't work. Sometimes it is about a bug. Okay, so you can submit this issue, and I'm gonna try to fix this. Now I have a way to test it, so I can test if that bug has been solved in that specific, for example, on Windows, on Mac OS, or whatever it is. Okay, Linux and so on. And so I can test it and then fix it. But sometimes you need to understand that is some problem are connected to the system itself. Okay, so like I was saying earlier, everything was working fine with the memory tracker when I was using Opus 4.6. I changed model, it was not working fine anymore. So I had to find a fix for that model. So I needed to basically filter the data so that model could actually work with the filter data. So what I'm saying here is you need to look at the tools that are part of the Resonant OS and then say, okay, how can I improve, make this tool, fine-tune this tool for my specific scenario? Because at the moment it's like having a Windows PC, okay, where the idea, remember the two things, okay, so we have Mac and Windows, okay, Mac build the hardware for the operation system. So having the hardware means that when you buy it, it's everything fine-tuned for that specific hardware. Windows need to work on any kind of hardware. And at the moment, the Resonant OS is more similar to that thing. Okay, I give you this that works with every single hardware. And like Windows, it doesn't work with every single hardware. That is the thing, okay? Some incompatibilities and problems and so on. So, but that, at the moment, this is the reality, okay? We can't do the Mac approach, because Mac approach means we need to have our own model or only be compatible with one single company. Okay, well, let's say, let's be compatible only with, I don't know, OpenAI or Gemini or whatever, okay? That would be a limit that we shouldn't take, okay? Because we shouldn't connect to one single corporation, and some people in some countries don't have access or the finance to actually work with those corporations. So what we need to do is to, at the moment, accept this reality. We are pioneers. Everything is broken, okay? We work with broken machine, but we build amazing things. So that is the message that I want to give to the community member, and the sense I'm doing the best to make it compatible with everybody. I can't test every single model, and sometimes, like I said, I changed the model, the system broke. So it was working fine until I had a different model. So that is one of the problems. My final solution to this, it's not final solution, but a good solution for this is to have an open benchmark, okay, which I'm building already, where you can connect your machine and run this benchmark, and then we track what works on your system to whatever level. Now, all of us as a community, we do it, and now we see how this model set up in this way can do this function really well, okay, because it's being benchmarked. So we can see, okay, now I can do this, and this, okay, I need to change these settings. So we can have the AI itself, Resonant OS basically, looking at this benchmark and say, okay, I can see how I can optimize your system now, okay, because I see through other people that this works better if you do this, this works better if you do this other. Okay, so now the AI can understand this thing and submit it to you and say, do you want to optimize according to the benchmark? Yes, I want to, boom, and then now I have something automatically that works better for my scenario. So this is what we can do with the community. This is not what you could have seen with the Windows, okay? So what we do, we create this that is open to everybody, whatever system you have, but then we track every single system so we can learn from it. Yeah, this is today's video, okay? There is a lot of things, and but yeah, so that is what we're doing. There is going to be more coming out. There is a lot of things happening behind the scene, and honestly, I'm going at a speed that is unbelievable. So that speed also translates in messiness, okay? This messiness is because I want to achieve one specific goal as soon as possible, which is allowing everybody in the community to actually participate. So there are going to be some specific action that we are going to take, and from now, by probably in the next few weeks, we are going to create a system where everybody can actually participate actively in the building of the DAO, the Resonant OS, and what we are building here, the community. There's but to do this, we need a way to stay aligned together and a way to work in groups and communicate and learn and improve. So there is a plan here, and come to the Wednesday Zoom call. If you're new to this channel, every Wednesday we have this community call, link in the Discord. Join there, because we're going to discuss those elements, and we need your help to move forward. Okay, thanks for staying until the end, and of course, like, subscribe, and watch the next video.